Question 6 from Section 1 of the 2019 Higher Physics Examination. A student makes the following statements about an elastic collision. 1. The total momentum is conserved. 2. The total kinetic energy is conserved. And 3. The total energy is conserved. And we're asked to find which of these statements is or are correct. Well, for an elastic collision, we know this. The total momentum is conserved. So the first one is correct. We also know for an elastic collision that the total kinetic energy before the collision and the total kinetic energy after the collision must be the same as well. So total kinetic energy is conserved as well. So far I've got 1 and 2. The third one, total energy is conserved. Well, energy is always conserved, so all the energy before the collision, if you add it all up and compare it to all the energy after the collision, you'll find out that it's the same. It is conserved. So the total energy before and after a collision in an elastic collision is conserved. So what answer we got then? 1, 2 and 3, and therefore our answer's got to be E for that one. Question 7 from Section 1 of the 2019 Higher Physics Examination. We're given an equation that we've not even seen before. The terminal velocity Vt of a skydiver is given by the relationship, and it's a complicated looking one. Vt equals the square root of 2mg divided by rho a and capital C small d. What does this mean then? Well, we're told that m is the mass of the skydiver, g is the gravitational field strength in newtons per kilogram, c subscript d is the drag coefficient. Remember, something travelling through air will be subject to drag forces, and that's just a special number describing the amount of drag that's taking place. Rho is the density of air, we've come across that before, and a is the area of the skydiver. Now comes the data part. When in free fall, a skydiver of mass 95 kilograms has a drag coefficient of 1 and a terminal velocity of 44 meters per second. The gravitational field strength is 9.8 newtons per kilogram and the density of air is 1.21 kilogram per meter cubed. And what we asked to find, the area of the skydiver. Now this is usually an exercise in rearranging an equation, which is a very important skill in physics, and that's why it's been tested at the higher physics level. So let's start off by writing down what the equation is anyway. The equation is going to be V. I'm going to leave out a small t so that it doesn't confuse matters much. We know V will represent the terminal velocity, and it's going to equal to the square root of twice the mass times the gravitational field strength, all divided by the density rho times the area times the c subscript d, which is the drag coefficient. So that's the equation we've got. And we have to try and extricate from that the area A. But we should have enough math skill to do that, because if we've got a square root on one side, we just square the other side. So we have v squared, and that's going to be equal to 2mg, because the square root disappears, divided by the density rho times A times C small subscript d. Now, we've still got to find that A, so keep a track of it, don't lose sight of it. So next thing we do is we cross multiply. So we have v squared multiplied by rho multiplied by A multiplied by C subscript d, and that should equal the numerator here, 2mg. So we're getting there. But remember, keep in mind what we're after. We're after this part here, A. Now to find A, we have to divide the right hand side, the 2mg, by everything except A. So we've got A on its own finally, and it must equal 2mg on the other side divided by v squared times the density times the coefficient of drag coefficient CD. And then we've got the formula for the area of the skydiver. Now all we have to do is be very, very careful. We've done all the amazing hard work here, and all we have to do is just put in the numbers. So in the numerator we've got 2 times the mass of the skydiver is going to be 95, so it's 2 times 95 times the gravitational field strength, 9.8. Put a bracket around that to help your calculation. Divided by V squared is the only tricky part, 44, and we have to square it. Remember, it's V squared. Multiplied by the density, and we found out that the density is 1.21, so 1.21, and then finally multiplied by the drag coefficient CD, which we're told is just 1, so it's multiplied by 1 at the bottom. Put a bracket around that. Now if you do that calculation on your calculator and take your time over it, you should get an answer of 0.79, which sounds about right, 0.79, and the units will be metres squared, since we're dealing with metres all the way through the calculation. Now, this is where you begin to panic. You look at the A, B, C, D and E, and lo and behold, you have got the answer there, 0.79 metres squared. Answer for this one will be B.